In tennis, one of the most important parts of getting the ball where it needs to go depends on the racket tilt. If the racket head is tilted forward when the head strikes the ball, rather than being exactly vertical, the ball will go in a different direction. Just like if the racket is open when the player hits the ball will go higher over the net than if the head of the racket was closed. For example, say that a ball approaches a racket at 80 miles per hour. If the racket is tilted forward and the ball hits the racket, the ball will bounce off of the racket at an angle downward with more topspin. This example would also be true if the ball is being served. With this tilt in the racket comes spin. What type of spin and how much spin is on the ball comes from the angle that you tilt the racket and how much force the person is pushing on the ball. When a player is up at the net volleying the ball, they will tilt the racket head more than it should be to ensure that the ball will land short on their opponent's court. In doing this, it creates the angle that the ball needs to bounce off of the racket so that the opponent will have a hard time getting to it. When the player opens the racket head up, it creates the angle that the ball needs to go higher in the air, and therefore if the opponent is at the net, it will go over their head and still land in the court. This concept is closely related, if not the same, as projectile motion. Projectile motion can be categorized as either full or half path. In tennis, the full path projectile motion would be when the player hits the ball from his side of the court to the other side, making a half circle shape. The half path projectile motion would be when a player hits the ball at the net or during a serve, making the ball then bounce at an angle towards the court. This is important because the half path shape and full path shape are closely related. With this, the ball travels with a constant horizontal velocity and a downward vertical acceleration. When serving a ball, acceleration occurs only in the vertical direction. It moves in a constant horizontal velocity, which causes its trajectory to look almost like a parabola.